Okay, so this is the solution video for paragraph response number 2. So in the first part of the question, it looks like we have an object that is going to be dropped a distance h towards Earth. So looking at the picture, we're probably going to be dealing with some type of energy within this problem because we have an object falling a distance. Okay. All right. So the first question says we need to determine whether the system containing only the object is open or closed with regards to the mechanical energy of the system, and state your reasoning. Okay, so if the system is only the object, so only this box up here, well, that box has an external force of gravity acting on it, which means that object is in an open system. Right? So our answer here would be the object is in an open system because gravity acts as an external force. Okay? So remember, open systems have external forces, closed systems do not. So then, okay, so then I want to add in, because I just realized that it's saying with regards to the mechanical energy of the system. So I want to add in that statement within my explanation. So the object is in an open system because gravity acts as an external force, which means mechanical energy will change. So it's not conserved in an open system. There we go. So now we need to determine whether the system containing only the object and the Earth is open or closed with regards to the mechanical energy of the system. And state your reasoning. Okay, so now our system is object Earth. Okay, so yes, there's still a force of gravity acting on the object, but now that we're considering the Earth, we also have to think about forces acting on the Earth. Okay, so this force of gravity represents the force of gravity from the Earth on the object. There would also be a force of gravity from the object on the Earth, and these two forces would be equal and opposite to each other, which means the net force on the system would be 0. And there's no other forces that we would need to take into account, so that means that there are no external forces, which means we're in a closed system and energy is conserved. So the object Earth system is a closed system because all gravitational forces are internal and energy is conserved. Okay, so let's go ahead and check out my scoring guide. So part A1, I get 1 point for stating that the system is open because there's an external force due to gravity, which changes the mechanical energy. So it's a good thing that I added in that part about the mechanical energy because that's how I get 1 of the points. Now that's a lot of information for 1 point, but that's how these questions work. Okay, now part A2, right, which was the object Earth system. So I get 1 point for stating that the system is closed, okay, because all gravitational forces are internal, which allows the mechanical energy to remain constant, which I did. Again, a lot of information for 1 point, but that's how these problems work. Okay. So then in part B, I need to determine whether the total momentum of the object Earth system increases, decreases, or stays the same. So one, I need to think about P total for object Earth. Okay, and then determine whether the kinetic energy of the object, so I need KE object, increases, decreases, or stays the same as the object falls towards Earth. Okay, so I'm going to go part by part. Okay, now the total momentum of the object Earth system. The object Earth system is a closed system. Okay, so that means two things. That means energy is conserved and momentum is conserved. Okay, now you're probably thinking, how is momentum conserved in the object Earth system? The object is the only thing that's moving, specifically accelerating, and it's accelerating downward, speeding up. So wouldn't that increase the total momentum? Well, if you were just thinking about the object as your system, yes. But here's the thing. The Earth, because it has this force of gravity acting on it, also has a very, very small acceleration acting on it. And because the mass of the Earth is so big, the mass times the change in velocity of the Earth, even though this change in velocity is so very, very small, ends up equaling the mass times the change in velocity of the object, okay? Which means, or they're equal and opposite because they're in different directions, which means that momentum of that system is conserved, okay? Which is super, super strange to think about, but that's how it happens. Okay, so let's write out that part first. All right, so we're going to answer the question first. So the total momentum of the object Earth system remains the same. Now, I know I was talking about the momentum being conserved. Conserved and remains the same means the same thing. Since they specifically say increase, decrease, or remains the same or stays the same in the problem, I want to use that same wording in my answer. So the total momentum of the object Earth system remains the same. This is because the object Earth system is closed. Any change in momentum of the object is equal and opposite to the change in momentum of the Earth, leading to the total momentum remaining the same. Okay, so that's the answer to question 1. Okay, meaning the total momentum of the object or system. So now we have to think about the kinetic energy of the object. Now, we should all pretty much know by now that when objects fall, they speed up. But we want to think about why. Okay, so the kinetic energy of the object increases as the object falls. Okay, so let's think about why. Well, let's actually, since we talked about system with our total momentum, let's go back to A, where we talk about the object being in an open system because of gravity. Okay, so the object is an open, nope, that's not how you spell. The object is an open system with gravity as an external force. Okay, so in an open system, how do we increase the kinetic energy of an object? Well, we do work on the object. So let's talk about some work. So since the force of gravity and the displacement of the object are in the same direction, so FG points down, the object is moving down, positive work is done increasing the kinetic energy of the object. Okay, so remember, that's the work energy theorem, the idea that work is force times displacement, and if force and displacement are in the same direction, you're going to add energy to your system. In this case, we're adding kinetic energy to our system. Okay. So let's just make sure we answered all of the questions. So we have total momentum of the object Earth system remains the same. So because the object Earth system is closed, any change in momentum of the object is equal and opposite to a change in momentum of the Earth, leading to a total momentum remaining the same. The kinetic energy of the object increases as the object falls. The object is in an open system with gravity as an external force. Since the force of gravity and the displacement of the object are in the same direction, positive work is done, increasing the kinetic energy of the object. Okay, so I've answered the questions and I've explained why. Okay, awesome. Let's check the scoring guide for this. Okay, so I get 1 point for stating that the momentum of the object Earth system remains constant. I did that. 1 point for saying that there's no external force. I didn't actually say that. Oop. Did I? Well, I said it was closed, which closed system assumes external force. So I would say that they would give us points for this, especially since we explained in part A2 that a closed system has no external forces. 1 point for stating that the kinetic energy of the object increases. For correct explanation as to why the kinetic energy increases, I did that. And a logical, so I wrote a good paragraph. Hooray, I got all 5 points. Let's just look at what their sample response says. So their example response says the object Earth system is closed with regards to the total momentum. So the momentum of the system remains constant. The system is closed because there's no external forces. By Newton's universal law of gravity and third law of motion, the force due to gravity exerted on the object from the Earth is the same magnitude of the force of gravity exerted on the Earth from the object. So they went a Newton's third law route with this instead of an equal and opposite momentum route with this. Still actually similar laws, though. Okay. So then they said the kinetic energy of the object increases because if treated as the system that contains only one object, the external force exerted from on the object from the Earth. As the object falls towards the Earth, the gravitational potential energy of the object Earth system is converted to kinetic energy, which increases the speed. Furthermore, as the object falls towards the Earth, the external force provides increasing the momentum, which increases the speed. So I'm not a fan of this response because they talk about the reasoning why in like 3 different ways instead of sticking with one. So there's like one reason, and then they talk about the object Earth system, and then again, they talk about just the object. So if anything, I would put this third sentence after that first one, where you're talking about just the object. But that's just me. Okay. So they went a little bit more in depth. They mentioned some other things, but my answer still got full credit. So it's not the more you write, you just have to be succinct and correct in what you write. Writing more is not necessarily going to get you total points. Okay. And that is the end for this paragraph number 2 answer or solution. Have a wonderful day. Oops, I accidentally opened my files. Have a wonderful day.